This is section 5.4. It's on medians and altitudes. This video, we're going to look at medians. Let's say that points A, B, and C are midpoints of the sides of a triangle. This is what that would look like. We know those lengths are the same if that's a midpoint. Also, we're going to know that these are the same, but not necessarily the same length as those. And then same thing with this guy. Make him different lengths, but make this one the same as that one. Those are they're midpoints. A triangle will balance at a particular point. This point is the intersection of the medians of a triangle. Well, what is a median? It's going to tell you here that a median of a triangle is the segment that goes from a vertex to a midpoint from the opposite side. Now you can do that from every single vertex. So there are 3 medians in a triangle, and where they cross is a special point. That special point is called the centroid. That's the balance point of a triangle. So really what happens is that centroid is going to split this big triangle into a bunch of little triangles, but there's a red triangle there that I highlighted. I'm going to use orange to point out this triangle. And I'll use yellow for this one. These 3 triangles, notice how they have 2 little triangles inside them also. But these 3 triangles, the red, the orange, and the yellow, they have equal areas. That's what that means. So that's the balance point. If you were to balance a triangle on a pencil, that's what that would look like. You would want to touch the centroid. Theorem 5.8 tells you about the concurrency of medians of a triangle. So the medians are all going to come together at one point called that centroid. Now, the lengths of these medians you can determine. If you know the length of the median, you can find the lengths of these 2 pieces. Or if you know the length of this little piece, you can find the length of this bigger piece and the whole median. Or if you know the length of this piece, you can find the length of the little guy and the whole median. Here's how this works. I'm going to give you a really easy example. Let's say that the distance from the centroid to the midpoint of one side of a triangle has a length of 5. Well, that same centroid to that vertex is going to be twice as long. It's going to be 10. What does that make the entire length then? How long is the median, F to B? It's going to have to be 15. 5 plus 10 is 15. That's one way to get it. If you have this little guy, multiply it by 2 to get this guy. If you have this guy, divide by 2 to get this guy. If you have this guy, you can multiply by 3 to get the whole thing. If you have the whole thing, you could divide by 3 to get this guy. Now, if you have this and you want that, there's different things you can do also. Obviously, you can divide by 2, then multiply by 3. Or if you have this guy and you want that guy, you can take this guy and divide by 3 and then multiply by 2. Divide by 3, multiply by 2, that's the same thing as 2/3 of something. So if you take 2/3 of 15, that's where you get 10. So a lot of people kind of have this epiphany about fractions in this section because 2/3 of something is the same thing as dividing it by 3 and then multiplying it by 2. And that's what this stuff tells you here. I find that this example is easier to understand than all of this, though. That's why I gave you that example. Use the centroid of a triangle. In triangle RST, point Q is the centroid, and the distance from S to Q is 8. Find the distance from Q to W. This is 8. It goes from the centroid to the vertex. That means that centroid to the midpoint of that side needs to be half that distance. It's got to be 4. Now, the whole entire thing, they ask you for that as well. This whole entire median, S to W, is going to be 12. 8 plus 4. Or 4 times 3. Same thing. Q to W is 4. S to W is 12. The vertices of triangle FGH are as follows. Which ordered pair gives the coordinates of the centroid P of triangle FGH? This one could get kind of complicated, but I think I know a simple way to find the answer. And I'm trying my best right here. But here's a triangle. It's going to have 3 medians. I know I need medians because they're asking me about a centroid. Okay? If I'm going to find this median, what I'm going to do is I need to find this midpoint of this segment. Between 2 and 6 should be 4, and between 1 and 5 should be 3. That's your midpoint. I just averaged these two and averaged these two. Notice how the median right here is a vertical segment. That's really, really important. Because if you want the centroid's got to live on this segment. So if it lives on this segment, the x value needs to be 4. Well, where would the y value be? So the centroid is going to be closer to the midpoint than it is going to be to that vertex, if you notice on those last few examples. So would it make more sense for the y value to be 5 or to be 7? 1, 2, 3, 4, 5, 6, 7. If it was 7, it would be closer to the vertex. It needs to be right here. That's where your centroid's going to live. This was kind of easy because I did this one first, and it was nice because it was a vertical median. If it was a diagonal median, I'd have to use my distance formula. I'd have to use my midpoint formula a couple more times. That's your guy. Depending on which one you go with first, makes the problem way easier. Here's some guided practice. We're going to find median lengths. There are 3 paths through a triangular park. So this is a park. These aren't clouds or blobs. These are trees. Each path goes from the midpoint of one edge to the opposite corner, meaning these are medians. So this guy, same as that guy. This guy, same as that guy. This guy, same as that guy. They meet at point P, so point P is a centroid. S to C is 2100. That's your entire median. Distance from P to S. Well, that's really easy. I know it's 700. If the whole thing is 2100, this guy is a third of it. You just divide by 3. P to C is going to be 1400. I know that because this guy times 2 gives you this guy. 700 times 2 gives you 1400. That's a really easy problem. If you have the whole entire median, divide by 3 to get the little piece. If you have the little piece, multiply by 2 to get the bigger of the piece of the median. Second one here, B to T. That's this guy. That's 1,000. How far is it from T to C? Well, if this is 1,000, T to C is also 1,000. They're the same. How far is it then from B to C, the whole thing? Well, each piece is 1,000. So B to C is 2,000. Last one, P to T is 800. That's this little guy. This little piece is 800. I know P to A is then 1,600. It's twice as big. And T to A would obviously be 3 times that. It'd be 2,400. And I know that I'm right because 800 plus 1,600 gives me 2,400. We'll do the altitudes next video.